going to present about project report presentation in fluid mechanics. We are from group 3. Our group members is me, Daniel Hakim bin Ismail. My metric number is AF220087 and Kifal Hafiz bin Azam AF220045. And then Muhammad Zulfahmi bin Muhammad Zin AF220048 and Juliana binti Muhammad Sulaiman AF220013. And the last one is Nur Hafiza binti Muhammad Saleh AF220021. We are going forward to our next presentation.
Assalamualaikum and hello madam. I'm Irfan Hafiz bin Azam. I'm going to present to you about introduction for our project. Pipe network analysis is the analysis of the fluid flow through the hydraulic network, containing several or many interconnected branches. The aim is to determine the flow rate and pressure drop in individual sections for the network. Pipe network analysis involves using mathematical models to calculate the flow and pressure of fluid through the pipe-in system. This calculation takes into account variation factors such as physical property of the fluid, the diameter, roughness of the pipe, and the elevation changes within the system. The result of analysis can be used to understand the behavior of the system, such as identify potential bottleneck or leak, and to optimize the system for maximum efficiency and reliability. Pipe network analysis can be applied in various industries such as water distribution, natural gas distribution, and oil and gas, chemical, and power plant industries. It's also important to utilize delivering water to consumer, natural gas distribution planning, or any piping system that require consistent delivery, pressure and flow. The Hardy cross is an interactive method for determining the flow in pipe network system where its input and output are known, but the flow inside the network is unknown. The Hardy cross method assumes the flow going in and out of the system is known and the pipe length, diameter, roughness, and other key of characteristics are also known or can be assumed. The method also assumes that relation between flow rate and head loss is known, but method does not require any particular relation to be used. In the case of water flow through the pipe, a number of methods have been developed to determine the relationship between head loss and flow. The Hardy-Cross method allows for any this of relationship to be used. Next, the total energy loss. The total energy loss in the pipe system, also known as head loss, is sum of the major or minor losses. Major losses occur due to friction within the pipe, while minor losses occur at fitting and other changes in the pipe direction or cross-sectional area. The major The major loss, also known as the friction loss, is caused by the resistance of the fluid to flow through the pipe that dependent on the pipe roughness, diameter, and fluid velocity. The major losses can be calculated using the Darcy-Weisbach equation. The Darcy-Weisbach equation is the most widely accepted formula for determining the energy losses in the pipe flow. In this equation, the friction factor is the dimensionless equation is used to describe the friction loss in a pipe. In laminar flow, For the friction, only function of the Reynolds number and independent of the surface roughness of the pipe. In fully turbulent flow, depend on the Reynolds number and the relative roughness of the pipe wall. In engineering problem, is determined by the using the Moody diagram. The minor losses, also known as the local loss, occur to the fitting such as elbow, valve, and expander. This fitting causes a change in the direction or cross-sectional area of the pipe, which result in the lost energy due to creation of the turbulence. Minor losses can be calculated using the equation for specific fitting. The total loss energy in the pipe is the sum of the major and minor losses, and it can measure in the unit of head loss such as meter or feet of head. It is important to take into account both of major and minor losses when designing a pipe system to ensure that system is able to deliver desired flow rate and pressure at the end of the pipe. The calculation for pipelines or pipe network can be complicated for the branch and loop. In this project, the analysis of pipe system will be carried by using the Hardy-Cross method and Darcy-Weisbach method. Thank you, and I will go to the next presenter.
For our problem statement, analysis of discharge Q is needed in every pipes for this water supply system in town A or figure 2 by using Hardy-Cross method with Darcy-Weisbach method as listed in table 1. The pipe diameter and length of pipe are stated in figure 2. Meanwhile, table 2 tabulated friction factor for pipe network according to a pipeline, and table 3 lists inlet and outlet discharge. So we need to do several tasks. And number one, complete the task given until correction for at least two loops reach 0.00 something's value. Number two, allow to ignore minor loss. Number three, any applications can be used to solve this task, for example Microsoft Excel. For our methodology, so, by using Microsoft Excel, the table of friction factor, length, diameter and K for the pipe is tabulated. The direction flow distribution is assumed and shown in figure. There are four loops to be calculated. According to the Hardy-Cross method, the total flow out should equal to the total flow out for every joint. It is considered that the clockwise flow is positive and counterclockwise flow is negative. For Q, each loop is calculated by using Microsoft Excel. The direction of the flow is assumed using a schematic diagram of the pipe network for loop 1, 2, 3, and 4.
Next, I want to talk about the result and the calculation of our project. The friction factor, inlet and outlet discharge, and the equation of head loss is given. Firstly, we find the value of K by using formula 8FL over pi square GD power of 5. The diameter of the pipe is given in the unit of inch. Therefore, we need to change it to meter by multiply 0.0254. This is the diagram of pipe network for trial 1, and we fill in the outlet and inlet discharge. Assume the direction flow distribution, fill in the K value and start the first trial. So this is the calculation for our result. We calculate the value of HF, which HF is equal to KQ the power of n, and n is equal to 2. We consider the clockwise flow is positive and counterclockwise flow is negative. Then we calculate the nkq the power of n minus 1. Last, calculate the correction theta q by negative sum of hf divided by sum of nkq the power of n negative 1. For the loop 1, the correction theta q, we get negative 0.0116. Next, for the loop 2, the correction theta q, we get negative 0.013122. Next, for the loop 3, the correction theta q, we get 0.0004249. Lastly, for the loop 4, the correction theta q, we get negative 0.01045.
This is the diagram of pipe network for trial 2. We assume the value of Q as follows. In trial 2, we copy paste the calculation in trial 1 and delete the value of the assumed pipe. So this is the calculation for our result. We calculate the value of HF. HF is equal to KQ power of n when n is equal to 2. Consider the clockwise flow as positive and counterclockwise as negative. The Q2 of the assumed pipe is calculated by sum up Q1 and the correction delta Q from each loop. So this is the result for trial 2. For loop 1, delta Q we got negative 0.0046975. Next, for loop 2, we got delta Q negative 0.0048841. For loop 3, delta Q we got negative 0.0030656.
So this is trial 2 loop 4. So the pipe, base of pipe 10, 11, 12 and 13. So our K for pipe 10 is 1724.899 and pipe 11 is 1037.986, while pipe 12 is 4945.699 and pipe 13 is 113.1573, while in Q2 is for pipe 10 is 0.00136, for pipe 11 is 0.05615 and pipe 12 is 0.03385 and pipe 13 is 0.00385. And the HF for pipe 10, 11, 12 and 13 is 0.00319, 3.2726, negative 5 for 6669, negative 0.00168, and total is negative 2.39279. And our n in a bracket of k q to the power of n minus 1 is 4.6912, 11.6566, negative 334.8240, and negative 0.8727.
Next, for conclusion, based on the project, a solution is required to find the information that has been taught. Thus, after the problem has been resolved, it is found that the Hardy cross process procedure is the method that are conveniently performed in tabular form. The solution would then be based on the Darcy-Weisbach equation. If used, the method will be simplified slightly. In each pipe, the first initial flow rates that satisfy the equation of junction continuity are selected. In conclusion, further information is gained on how to implement the Hardy-Cross method for this project, as it provides a scheme for measuring the value of the correction to be made, considering and correcting each loop or junction in turn, assuming that the conditions remain unchanged in the network remainder. That's all for us. Thank you.